So in today's video, we're going to graph transformations of sine and cosine. So let's actually go and recap some of the features of what A, K, P, Q actually tell you about the function. So let's begin with the A. So the A tells you the amplitude. It tells you the height of the bump and the height of the valley of the function. So amplitude. And it also tells you something about the reflection, depending on whether there is a reflection or no reflection. The last one here, Q, tells you the equation of the axes. It tells you the middle line where the bump is above and where the valley is below this horizontal line. This K value here tells you something about the size of the period. So if the K is equal to 1, there's no change, meaning the period is going to be 360. However, if K is different, then the size of the period or the length of the cycle is going to change. P is called the phase shift. So in other words, the shifting left or to the right of the sine or cosine basic graph. So we're going to take all of these and we're going to put them together and see what the graph of a transformed sine or cosine wave looks like. And just to add on K, if it's negative, there could be a reflection. So let's have a look at the sine wave. I want to address the reflections either over the x-axis or over the y-axis. So when we actually start off with a negative in front of the sine x, they're about to ask you to graph the negative sine x. What does that mean in terms of the a being negative? Well, that means the entire red graph is going to reflect over the y-axis. So what that means is, imagine this bump here being flipped over the x-axis is going to be somewhere down here. Imagine the lower bump becoming the upper bump, the upper bump becoming the lower bump. So all the valleys will become the peaks and all the peaks will become the valleys. In other words, the graph is going to look something like this. So I like to start from the 0, 0. So what's going to happen here is that this is going to go down and then it's going to go back up. So everything is going to be reflected. So this is the negative sine x. So let's have a look at another reflection, which is negative x. So what that means is here the k value is negative 1. So when the k value is negative 1, something is happening horizontally. Well, what does that mean? Well, it means that the sine wave, this red graph here, is going to reflect over the y-axis, so over here, if you can see here. So what that means is we're going to take all the right bumps. So see this right bump over here. This bump here is going to be over here now. So I'm just going to draw a dotted line. Now this lower bump over here, right over here, is going to flip to the right-hand side. So it's going to be something like this, and vice versa. So we're going to do this. So this is going to look like this. And you might think, well, isn't this the same graph as the other one that we just did? And the answer is yes. So what that means is, over here to the left, if you reflect over the x-axis graph, it's the same thing as reflecting over the y-axis. So in other words, these two are the same because we end up with this dark graph at the end, whether we reflect it over the x-axis or the y-axis. Now, what happens if we reflect double reflection? So what does that mean? It means if you take the function and double it, double reflect it. So what do you think is going to happen? So right over here, we already have a single reflection in the one in the black. So if we do another reflection, what's going to happen is that the red bump, the black bump here is going to go back to the original start. So meaning it's going to go back to this blue part here, which essentially is the red part here. So in other words, if you do a double reflection over both axes, this graph here is going to essentially look like the original red graph, which is this one here, which is a basic sine wave. And when you get to grade 12 advanced functions, this property is actually called odd symmetry. Odd symmetry means is if you do a double reflection of a graph and you end up getting back to the original function, that means it's odd symmetry. Next thing, let's look at the cosine graph. So what happens if you if you reflect it across the x-axis? So everything, all the upper bumps, all the valleys will become peaks, all the peaks will become valleys, and we end up getting the following. So I'll just draw this in red. So we're going to get something like this. So we're going to get something like this. Okay, so the next thing I'm going to do is, well, what happens if you take the original graph and you reflect it on the y-axis. So let me just erase the red part here. And what happens if you take the blue and you reflect it across the red, across the y-axis? Well, remember what I said? All the right-hand side part will become the left-hand side part. In other words, if I take this part and if you flip it across the y-axis, you're going to end up getting here. And vice versa, if you take this blue part here and reflect it over the y-axis, you end up pretty much on the other side. So in other words, if you mirror image this on the y-axis, you're going to end up with the same function. So take this part here, flip it over across this y-axis, you're going to end up in the same opposite spot to the other side. So in other words, when you reflect on, so this graph here, when you reflect it over the y-axis, will give you exactly the same thing as the original graph. So having a reflection for the cos wave has no impact on the original graph. So meaning it has no difference. However, if you reflect it over the x-axis, what's going to happen, and like before, let me just erase all this stuff here, we end up with something different. It doesn't overlap itself. We actually end up with this one over here. So something like this, all the values become peaks. So in this case, this is not true. And the reason why I'm talking about reflections first is because sometimes you don't have to address the reflections depending on what kind of reflection it is. So what I mean is, if I see this, I don't really have to think about reflecting because I know the graph is going to be the original basic cosine wave. However, if I reflect it over the x-axis, I know it's not going to be the original graph. It's going to have, all the values will become peaks. So now let's try to start easing into graphing the transformations of, in this case, a sine curve. So let's actually analyze each piece first. So we know that the amplitude, so it's always good to write things down. Amplitude is 2. It's not -2, it's +2. I'm going to make note that there is a reflection on the x-axis. So all the bumps will be, all the valleys will become peaks and the peaks will become valleys. And the next one is the 3. Well, what does the 3 tell you? It doesn't tell you exactly what the period is, but it's going to show you how to get the period. So the period for any basic sine wave is going to be 360. However, when k is 3, we know that from previous lessons that when k is bigger than 1, something's going to happen horizontally. Well, is it a horizontal compression or horizontal stretch? And k's are a little bit different when it comes to horizontal. It's going to be a horizontal compression, meaning the 360 degrees is going to get smaller. When it gets smaller by a factor of 3. It's going to shrink by 3. So the compression is going to go to 120. What that means is, if I were to draw a sine wave like this, from here beginning to the end is going to take 120 degrees instead of 360. The next one here, 60 degrees plus negative 60 degrees means you're going to shift. So put here, phase shift to 60 degrees to the right. And then the last one here, the 1 actually tells you the equation of the axes, which is y is equals to 1. So once we have all the features, let's actually start graphing. And step 1, I'll put here on the side, I'm going to advise there's many ways to graph, but I'm just going to show you one way, which is the method that I'm going to carry on for those that are going to be in my class for in grade 12. Always graph the equation of the axes. Always graph EOA. So in other words, y is equals to 1. So I don't have any grids here, or I don't have my x-axis. So let's actually start off with the x-axis. Let's just draw a horizontal line. Okay. Now, if we notice here, I'm going to also have to draw my y-axis. So let's draw an y-axis here. Here's my y and here's my x. The first thing I'm going to draw is my equation of the axes, so which is 1. So 1 is over here. I'm going to use red, and I'm just going to draw a dotted line, indicating that this is the EOA. Now I know that above the, there's going to be a bump over the line and a bump under this line here. And what is that bump going to be? Well, the bump is going to be, has an amplitude of 2. So what that means is we're going to figure out the maximum and the minimum of this graph here. Also use red. So when I say 2, I'm going to count up 2. So here's 1, and then I'm going to count up 2 boxes because the amplitude is 2 to number 3. So that means my maximum is going to be 3. I'll put here, and my minimum is going to be Well, you start from 1 and you go down 2 steps because the amplitude is 2, and we know that our minimum is going to be at -1 right over here. So all I'm going to do is just draw a horizontal line indicating my maximum minimum. That means my graph cannot go above the 3 or below the -1. And for those that like to see calculations, I'll put on here in the bottom, the maximum here is the EOA plus the amplitude. The minimum is the EOA minus, because you're going to go below that line, the amplitude. In other words, in our case, it's going to be 1 plus 2, which gives me 3, which is the maximum over here. And we have 1 minus 2, which equals to -1, which is the minimum over here. So the graph is pretty much set vertically up and down. Now we have to figure out left and right. Now, where does this graph begin in terms of left or right? Well, it says here that there's a shift of 60 degrees to the right. So on the bottom left-hand side here, I'm just going to write down, it begins at 60 degrees. So the graph's going to start and go up and down. So up and down, and it's going to end up somewhere over here. But what is it going to be? Where is it going to end off? Now keep in mind, what does the period mean? The period means to start from here. It's the distance from the beginning to the end. And in this case, we know the distance is going to be 120. So you start at 60 degrees, but you have to tag on 120 to figure out what you're going to end off at. 60 plus 120 is going to be 180. So I know that somewhere on my scale, I have to have a 60 and a 180. And I think that when graphing, choosing the scale is the most difficult part. So I'm going to give more room. What that means is I'm going to let every single box be 20. So here's 20, here's 40, and here's 60. So every 3 boxes is worth 60. So this is 60, this is be 120, and this is going to be 180. And I'm going to also go backwards too. I'm going to call this -60, -120, and -180. The reason why I'm having more left-hand side, right-hand side, because I'm going to ask you guys to graph at least 2 cycles, like an up and down and an up and down, or down and up, depending on the reflection. All right, now we get to start to graph. So we know that the graph starts at 60 degrees. I'll put here in the arrow here, this is 60 degrees. But where does the graph begin for a sine wave? Does it begin at the max? Does it begin on the middle? Or does it begin at the lowest part? Well, and if you look at the left-hand side right over here, we can see that the sine wave begins in the middle on the equation of the axes. So I know right now that my first dot is going to be 60 to the right, which is over here in this area here, but I'm going to start on the middle line, the equation of the axes. And I'm going to erase all this other stuff here, which we don't need anymore. So that's my first dot. Well, we have to look at the next dot. Well, this is the beginning of the cycle over here. Well, where does this dot come back? Well, it comes back at 180. So in other words, I'm going to draw a dot on the equation of the axes. It comes back at 180. So here is my other dot. But hold on. A sine wave includes an upper bump and a lower bump. So what that means is we are going to have to figure out this over here. So here's my beginning. Here's my end, but I know that I'm going to have to cross again the middle point. So where is that middle dot going to be? Well, it's going to be between 60 and 180, and based on our scale, I know that 120 is going to be the middle dot. And now we're going to connect the dots. Now the question is, you know that the graph here, a sine wave goes up and goes up, if you look at the left hand, and down. But hold on, we have a single reflection. So instead of going up and down, we're going to have to go down and up. So the reverse. So the last thing is I'm just going to start from here, go down and go up. So there's my valley. And at the same time, if I keep on going, I'm going to go up and down. So there's my upper and lower bump. And this is just one cycle. But if I want to draw in more cycles, I could keep on going with this. So down and up and down. And then of course you need to put the scale. So the scale goes up by 60. So 180 plus 60 is 240. And another one is going to be 300. You don't have to go to the right. You can always go to the left. So if I go up and down, so I know that this part here is going to go up and then down. So it's always good to draw the dots first. And I know that for me, every 3 boxes is where that black dot is. And then I can connect the dots, go down and up and then down. Okay, I don't have a perfect grid, but this is pretty much the best I can do based on what I have. And here we go, there's our graph. And put arrows at the end because this graph keeps on going forever. The reason why is I did not give you a restriction. We'll assume that x is ER, meaning it keeps on going forever. I'm going to just change something here. What happens, miss, if you add a double reflection? Well, what happens? Well, if you recall before, when you double reflect sine, you actually go back to the original wave, meaning you got the upper, the peak, and then you have the value. So if I added a double negative here, double reflection, the only difference in this graph is, I'll use yellow, is that the graph, which starts from 60 here, all right, instead of going down and up, we're just going to go up and down. So the reflections don't really change the original graph, meaning you go up first and then down like the basic wave. So having a reflection, double reflection, does not really make the question more difficult. It just, you got to figure out whether you go up and down or down and up. It really depends on the reflection. So I think right now it's a good time for you to pause and figure out the 4 features to the left, to the right. So can you tell me what the amplitude is, the period, the phase shift, and the equation of the axes? So now's a good time to pause and see whether you can calculate these 4 pieces. So the amplitude is the very first number that you see, which is 2. Now the k value, which is negative 0.5, so the k value, I'm going to put here, there is a reflection on the y-axis, and we'll come back to that later when we start the graph. So the k value is in fact 1 over 2. I'll put it into fractions, and 1 over 2 is less than 1. So what that means is it's going to be horizontally stretched by 2. So what that means is instead of 360, it's going to be stretched. When something is stretching, it gets bigger, so you're going to multiply by a factor of 2. In other words, our period is going to be 720. Over here, we have the EOA being negative 3, that last number here. And this is where you have to be careful for the phase shift, because some students will think, oh, it's negative 15. That means I'm going to move to the right 15 degrees. However, look at the entire format. There's something that you need to do before you actually figure out the phase shift. You're going to have to factor out the entire k value. In other words, when you divide things by negative, it becomes a positive. But what's 15 divided by 0.5? You end up with 30 degrees. This should be degrees. In other words, our phase shift is 30 degrees to the left. So let's start graphing. So I'm going to use red again. So red, first things first, always graph the negative 3. The equation of the axes come first. So negative 3 is down here. So put here, I'll put a dotted line here, indicating that is the EOA. I'll put y is equals to negative 3. And from this, we can figure out the max and min. So we know the amplitude is next. Let's figure out the maximum. So remember, amplitude means you start from the equation of the axes. You start from the equation of the axes and you go up 2 steps. Or to find the lower part, you go down 2 steps. So in other words, if I were to physically graph the max and min, I'm going to put in green over here. So this is my max, which is in my case, the max is going to be y is equals to negative 1. And my minimum, which is the lower green part here, is going to be negative 5. And the entire graph has to be between here and here. It cannot go above or below. So above axis is above the top green line, you cannot draw anything. Below the green line, you cannot draw anything. Everything has to be between. Okay, all right, let's figure out where we start. Well, let's deal with the phase shift right now. So next step is phase shift. So I'm going to put here on the right-hand side. That means the graph starts at 30 degrees negative. So you're going to start at negative 30 degrees. So that's your beginning of the wave. Now the question is, cosine wave looks like what? It starts at the top, middle, or the bottom, the basic cosine graph. So the basic cosine graph starts from the top, and then it goes down, and then it comes back up. So that's the beginning of the shape of the cosine graph. And so the period is what in this case? It is 720. So 720 degrees. So you start at negative 30 degrees, and you got to figure out where you end off. So you take negative 30 degrees plus 720, which gives us 690 degrees. And here is the issue right now. We need to figure out a scale that fits these 2 numbers. And I hope we have enough room. I'm not too sure, so let's test it out. So for me, in my particular example, I had to change my y-axis and move it more to the left because I have to go all the way up to 690. So I'm going to start at negative 30. So I'm going to let each box be 30 degrees. So here's negative 30. So I'll put here 30, 60, 90. So every 3 boxes is worth 90. So that means this is 180. So 180. And then we have 270. Then we have 360. So here I just set up the scale, so I'm going to let each box be 30 degrees, and I need a lot of room to my right, as you can see, because this number is huge. So this number right here is the end of my cycle. So I'm going to begin here, and then one cycle up and down should end up being here. So where does this dot begin right now? So the question is, let's look at the green and the red and the green. Where does the cosine wave begin? Well, it doesn't begin on the red line because that's where sine begins. It begins either the top or the bottom. Well, how do we know if it's the top or the bottom? We have to look at the reflection. So keep in mind, this is what the graph looks like, all right? It usually begins max, min, and then max. So if you notice here, it's positive, so we don't have to flip anything. So this part here doesn't start lower part. But miss, there's a negative reflection in the y-axis. So when you reflect a cosine wave, so let me just draw the y-axis. And let's actually draw the EOA here, and I'm just going to continue the cycle. Okay. If you take the cosine wave and reflect it on the y-axis, you end up getting the same graphs. Imagine this part here reflecting to this side here, and this side here reflecting to the right. So you don't really change the shape of the graph. So what that means is this here, this negative reflection, has no effect on the graph. So meaning the cosine graph are basic. So in other words, you're going to start, the graph's going to start at which area? Well, we know that's going to start at negative 30, but it's going to start at the very top, And we know that this dot is going to come back at 690, which is over here, so somewhere over here. Now keep in mind we have to draw the minimum point here, and the minimum point is halfway in the cycle. If this here is the beginning and this is the end, that means somewhere here will be the minimum. And how are we going to calculate exactly where that minimum is? Is it 360? Is it 330? Well, we're going to have to find the midpoint, the halfway point between negative 30 and 690. So all we're going to do is let's do some calculations at the bottom. Negative 30 plus 690 divided by 2 gives me 660 divided by 2, which is 330 degrees. So what that means is 330 is over here, 330, and I know that I'm going to draw the minimum dot here. So the next thing is, well, I'm going to use yellow. It's just connecting the dots like this. And the answer is no. Keep in mind that we have to have a peak and valley. So when I say valley, it has to be curved, something like this. Something like a half a curve, like a half a bump here. But as you can see here, this is a really rough sketch. I want it to be a bit more accurate, so I'm going to erase all this stuff first. So the next thing we need is 2 more points. So when I say 2 more points, if we refer to this part here, we're going to figure out where the cosine crosses the equation of the axes. And if you compare this one here and this one here, the point over here is actually the midpoint between the beginning, the highest, and the lowest. So in other words, if I want to find the point somewhere, I'll call it the quarter point here, somewhere here is going to be where that dot passes through. But how do you find this area? Is it 180? Is it 150? Well, let's do the midpoint between this dot here, the beginning point, and the halfway point. So let's find the midpoint just by adding these two. So you have negative 30 plus 330 divided by 2. That will give us 150. So what that means is my dot here is going to be right over here. Remember that each box is 30. So this over here is 150. I'm going to draw my dot right over there. So take my point here and over here. And we do the same thing. So we do the same thing for here, the other side here. To find the other point, we're going to have to find the midpoint between the lowest x value, which is 330, and 690. And we end up getting the following. Let's actually do the calculations. We take 330 plus 690 and divided by 2. And that's going to give us 510. So 510 is over here. So this is 540, so this is 510. I'm going to draw my dot right over here. So my dot is going to be right over here, and then I can draw the dots. Now, when you draw your connected curves, just make sure that you have a smooth bump valley. So I'm going to do this first. I can see that this is my lower bump, so I'm going to just curve it And then after that, I know that from here to here, I'm going to have to curve it sort of like a parabola-ish, so curving down. This part here, I'm going to have also here curving down. And now we have one cycle. And the question is, do you have enough room to draw another cycle, meaning you continue on? And the answer in my case is no. But if you had graph paper and you can change the scale, I'm sure you can include another cycle. So here I'm just going to summarize what we've done, and when we do our live videos for online class, we're going to actually address all of these again. So first things first, when you get your equation, make sure you get the EOA. Always draw the EOA first. And then after that, you do the max and min. So max and min, remember, you use the EOA to get the max and the min by adding or subtracting the amplitude. The next one is, well, you need to start the graph. So this is where your phase shift, so that p-value, shifting left or right, if there is a phase shift, and you got the starting point, and now you got to figure the ending point. Starting point is simple because the function will tell you what it is, either factored form or not factored form. Then you need to figure the end point, and this is where the k value helps you to figure out the period. And all you do is to get the end point, you just add the period to your starting point. Once you have that, the most difficult part, I think, is the scale. Figuring out the scale that would fit at least a cycle or more, or 2 cycles on your graph paper. Once you have your starting point, you have to figure out, well, where are you going to start? Are you going to start at the max? Are you going to start on the EOA, the middle line? Or are you going to start at the min? And that really depends on the reflections, if there's any reflections. And of course, depending on the sine and the cosine graph. Sine always begins in the middle. Cosine begins either at the max or the min, depending on the types of reflections. When I say up and down, the very last thing is up and down. Well, sometimes if you start from here, well, do you go up first and then down, or do you go down and up? And as I said again, it also depends on the reflections, which depends on the A and the K.